Now, this is another compound. Remember, I said that when we see compound like this, we firstly count the total number of carbons that give us the highest count, and that one will give us the root name, the parent name. So now, let's count. We can count straight, we can count in an angular manner, but we cannot count zigzag. So if we count like this, 1, 2, 3, 4. So we have 4 here. If you start counting from here, 1, 2, 3, 4. So irrespective of the way we are counting now, is giving us 4 numbers of carbon. So we can just pick the straight one for convenience. 1, 2, 3, 4. So 4 there is butane. And this is the family of alkane. Then you end it with A-N-E, butane. That is the carbon. Remember that we can count like this: 1, 2, 3, 4. Now, so if you are counting like this is an attachment. This is an attachment, and this attachment falls on carbon number 3. But if you can't start counting from this another end, 1, 2, 3, 4. This attachment falls on carbon number 2. And what is the name of this attachment? Because it is CH3, it is called methyl. Because it's CH3, it is called methyl. Okay? Now, and it falls on carbon number, if you count from this beginning, from this left, this attachment falls on carbon number 3. If you start counting from right, it falls on carbon number 2. According to the rule, we are going to pick 2. Because 2 is lower than 3. So in this case, we'll be having 2-methyl-butane. So the real name of this one is 2-methyl-butane. Now this is another compound, and this one is different from the one we've been doing since, with just a little different. Now we are having 2 different attachments here. We have this one. We call it allo group or chloro group. Let's just say allo group. Halogens in the group cell, they are group cell elements which include fluorine, chlorine, bromine, iodine. They are called allo group. So, and then we also have alloalkane. Alloalkane means when we have any halogen atom combined with any halogen member combined with the family of alkane. In that case, when we have two different groups here now, this allo group will be given priority over methyl. But firstly, let's determine our root carbon. I mean the longest carbon. We can count like this: 1, 2, 3, 4. 1, 2, 3, 4. So our longest carbon in this diagram is butane. Our longest carbon is butane. And so if you count like this: 1, 2, 3, 4. And then you can also count like this: 1, 2, 3, 4. Okay, so we are going to give respect to chloro group because he is the owner of this compound. There is alloalkane, and also chlorine is highly electronegative than methyl. So which means that chlorine is powerful than methyl, and we are going to give regards to that. So because of that, we rather start counting from here. Because of this chloro group, it has restricted our counting from left side. So we start counting from the left hand side now, and then our chloro group is 2, our methyl group is now 3. Since we are having 2 different attachments, we are going to arrange them alphabetically. This one is chloro, which is C, it starts from C, and this one is methyl, which stands from N. So now the chloro group the name become first, which is because it is the name starts with C, chlorine, and then it falls on carbon number 2 here. So we are having 2 chloro, 3 methyl, butane, 2-chloro-3-methyl-butane. Now that's the name of this compound. Remember, how do you arrive at here? You firstly determine the root name, the longest carbon, which is butane, and likewise our methyl group first on carbon number 3, our chloro group first on number 2, and we arrange them alphabetically. C comes before N, so that's why you can say 3-methyl 2-chloro. It will be wrong because C comes before N. Do you understand now?